Hello and welcome to my next video. Over the past few weeks I've been designing some circuits, and the first one has just arrived from China. This one is designed to adapt the tachometer signal from the Subaru ECU and convert it into the tachometer signal that the VW tachometer itself requires for type 25, type 3, etc. It also turns the tacho signal into a speed signal so that the ECU doesn't go into limp home mode. It does fuel and fan and other such things as well, just to help the ECU along its way. I'm working on this board in conjunction with Nick Tune of Subaru Surgery. Anyway, I designed the PCB in KiCad, which is an open source schematic and PCB designer. I sent the PCB files off to JLC PCB in China, along with a bill of materials and some other stuff, and they actually built and assembled the PCBs. So it's just arrived in the post from DHL. Thank you very much, DHL. So I'm going to unbox it now. Packets are difficult to get into. I'm super excited to open this because it's the first time I've used this company. I've actually ordered a few more things from them as well, but wait for another video to see what those designs are. So they can assemble a lot of the surface mount components on the board, but they don't have the specialised chips and things that we need for this. Actually, in this one, I've designed it to take an Arduino Nano, and that Arduino Nano will be doing all the interfacing and adapting the signals and things like that. In a future design I may actually build the chips directly onto the board. Anyway, so a nice box from JLC PCB. We open that up. We have a jigsaw. I'm not sure why they sent me that, but it's just a free gift, I suppose. And then we have the actual boards here, all wrapped up in cling film. So let me just get into this. Okay, it's just wrapped in cling film. So let's do that. Unwrap that. Here we go. How much have they used? Well, more than enough, but that's good. It's good to see them properly packaged. I can throw that away later. Now, here we go. This is the moment of truth. I'm particularly interested to see the quality of and accuracy of the PCBs themselves, and I'm also interested to see the quality of the soldering and the assembly. So here we go, the boards themselves. So they're all still sort of attached together. I don't know whether they're taped together or they just snap apart. I think they just, oh no, they've got tape on the back. So let me just pull one of these off. And take a good look at it. So here is the PCB itself. It's assembled on one side. It uses surface mount components in the majority, but you see here there's so already holes for a pin header to solder an Arduino to the board. As I said, I'm actually interested in putting the microcontroller itself on the board, but this is a prototype, so I can use it to develop the software, the firmware on board, and then see how it goes, and a later revision will have the may well at least have the microprocessor on board itself. So there's a few interesting things on here. There is a variable resistor. This board also outputs a signal for the temperature gauge, so that allows you to calibrate the temperature gauge. We have a regulator on here to protect the Arduino. There's a couple of there's a fuse I put on here. There's a diode to protect the regulator from reverse polarity. And there's all sorts of things on here as well to protect the input ports on the Arduino from high voltage surges and things like that, so clamping diodes and Zener diodes and all that kind of stuff. So there's a transistor for switching the tachometer on the VW, and the idea is to have Wago connectors on here, and they're really good because rather than screwing onto the wire, they actually clamp the wire with a simple lever. So when I install that, I shall show you how that works. Anyway, super excited to build this. Looking forward to testing it out. Thanks for watching.